Good afternoon, ma'am.
Morning, Kavya. Am I audible?
Yes, ma'am.
Any doubt from the last class?
No, ma'am.
Have you tried the questions related to Daniel's L2?
Yes, a few basic ones.
Huh?
Yes,
Basics you
ma'am.
have done.
Yes.
So you were able to solve the questions.
Yeah, a few of them, yes.
Today we will start from some basic terms, electrochemistry.
Uh-huh.
Okay? Or we can say that we will start with basic terminology. Okay? The first term that we have is the redox couple. Okay? What is redox couple? When we learned about the Daniel's, in that I was always saying that I'm having one container, two container, and sometimes I was calling them as half cell. You getting?
Yes, ma'am.
Okay. So basically, what was happening there? In one of the container, that is the first one in which the anode, I said that anode, where oxidation was there, right? And one was cathode where reduction was. Is it so?
Yes, yes, ma'am.
Okay. As I can see that on the anodic part, what was happening there? It was the oxidation. Zn is getting converted into Z into positive, right? On the cathodic part, there was a reduction. These copper to positive ions were converting into copper,
Proper. Yes.
right? As I can see that this one is the half reaction
Yes,
and
ma'am.
this one is also the half reaction. So I can say that this one is the half cell and this one is also a half cell. So combining these two cells, what I get basically the redox couple, as it always works in couple form. Why redox? Because it is the process where both oxidation and reduction taking place simultaneously. That's why I said that it is the redox, as it is happening in the form of a couple, like both of them work simultaneously. That's why I call it as couple. Got it?
Yes, ma'am.
Next is terminology that I have is the standard electrode potential. Before knowing that what is standard electron potential, I have to know that what is electrode potential. When we were doing the reaction now, there was the electrolyte in this half cell and it was an electrode. In this, what
Yes.
was happening that zinc is getting converted into Z into positive ions. When zinc is getting converted into Z into positive ions, it means the electrons were over the electrode. So on the electrode, there were electrons and in the electrolyte, we are having the cation. Correct?
Yes, ma'am.
So negative charge on the electrode and positive charge in the electrolyte, that creates a potential difference between the electrode and electrolyte. Basically, that electrode potential difference between the electrode and electrolyte is the electrode potential. What is electrode potential? It is the potential difference between electrode and electrode. Is it clear? Getting
Yes, ma'am.
example we can see in case of Daniel's. I told you earlier that whenever I was considering the anodic part, the zinc is getting converted into Zn positive. So electrons were on the electrode. As the electrons were on the electrode, so this one is the negatively charged. We
Uh-huh.
discussed this
Yes,
thing
ma'am.
yesterday.
Yes, ma'am.
And in the case of cathodic one, we have positive charge on the electrode. Correct?
Yes, ma'am.
So we can say that in Daniel cell, cathode has positive potential with respect to solution. Getting?
Yes, ma'am.
Or I
Okay.
can say that anode has negative potential with respect to solution. It is in the case of Daniel cell only, or I can say that in case of electrochemical cell. Because in electrolytic cell, it reverses. Getting?
Yes, ma'am.
Next is the terminology that is the standard electrode potential. When we use the term standard, basically, when I was using the electrolyte, if that electrolyte is of one, that time we can say that our potential that is generated is standard. We can say when concentration of all that is getting involved, species involved in half cell is unity, standard. Getting?
Yes, ma'am.
Is the difference between what is electrode potential, what is standard electrode potential is clear to you?
Yes, ma'am.
We have two types of standard electrode. One is the oxidation standard electrode potential and other is the reduction standard electrode. Standard electrode potential we represented by E naught and electrode potential we represent by only a single E. When we talk about standard, we place a naught over it. Got it? As
Yes,
standard
ma'am.
electrode potential is of two types, E naught. So how can we detect that if we are given the potential, then how can we decide that which one is the standard electrode potential for oxidation or which one is for reduction? Any idea?
No idea, ma'am.
Okay. So by seeing the convention now, that if E naught is given for both, if I write it like this, in this what I can see that M is getting converted into Mn positive. Number of electrons can be something. If I say that I am considering zinc, then Zn is slash Zn2 positive I will write,
Yes.
right? It means zinc is getting converted into Zn2 positive. So by seeing this subscript now, we can decide that my standard electrode potential will be for reduction or for oxidation. If it is given for reduction, then it will be written like this.
Okay.
Got it?
Yes, ma'am.
Any doubt from this part?
No doubts.
The next terminology that we have basically the cell potential. First, we learned that electrode potential. What is electrode potential? It is the potential difference between electrode and electrolyte in a single cell base. What is the standard one? When the species is unit. And now we talk about cell potential. For cell potential, we consider both the half cells, like the anodic half cell and the cathodic, or the oxidation and the reduction. Got it?
Yes, ma'am.
Cell potential is also called as cell electromotive force. Represented by E and cell. It is basically the potential difference that is generated between the two half cells, right? Potential difference of one and the potential difference of two. Their difference is called the cell potential.
Okay.
It is the potential difference between electrodes L. Got it?
Yes, ma'am.
The cell potential is always measured in volt. Volt is the unit for cell potential. It is represented by E cell. When we call cell potential as cell electromotive force, when no current is drawn to the cell. At that time, we say that the cell potential is that. It only happens when there will be no current. Is it clear?
Yes, ma'am.
Now the thing is that how to find out the cell potential. Here the formula for cell potential is E cell is equal to E cathode minus E anode. Basically, the cell potential of cathode minus the cell potential of anode. Okay.
Yes, ma'am.
Now the thing is that which potential we take. We have two types of potential, oxidation potential and the reduction. Discussed now that we are
Yes,
having two
ma'am.
types of standard potential. So
Yeah,
by
ma'am.
default, we always take the reduction potential.
Okay.
Got it?
Yes, ma'am.
This we will do later on, that how to do. Next is the self-representation. Like verbally, we are saying that we have made a half cell, a anodic half cell of zinc, and zinc is getting converted into positive and like this. If we want to represent it in a single line, okay, then that single line is basically the cell potential. Cell represent. It is represented by. Are you getting the terminologies now that I'm teaching to you?
Yes, I'm understanding.
Considering electrochemistry as an easy topic. It is represented by putting a vertical line between metal and electrolyte solution. Double vertical line, two electrolytes connected by salt. Like in the Daniel cell, we are having this code, and here are two copper as well, right?
Yes, ma'am.
Anode one and the cathode. While representing the cell, we always write the anodic part first. So what is happening in anode? Zn is getting converted into Zn positive, 2 positive, right? So we will write
Yes.
Zn, vertical line. The physical state of Zn is solid. So we will write solid over. Vertical line is getting converted into Zn2 positive, that is in active. Correct? Getting?
Yes, ma'am. Getting.
What is happening in the cathodic one? Copper 2 positive is converted into copper. So copper
Yes.
2 positive aqueous is converted into vertical line. Copper, can I write it like this? And both the half cells are separated by double bond. This is basically the cell representation. First one is the anodic one, where oxidation is taking place. Second one is the cathodic one, where reduction is taking place, and both the half cells are represented separated by a double line. That is our salt. Here,
Yes, ma'am.
I have one more example. If I give you this cell, I simply write this. Now tell me that what information you get by seeing this represent.
The cathode is anode contains copper and cathode contains silver.
Yeah, so oxidation is of copper taking place. Like copper is getting oxidized and silver is getting
Reduced.
reduced, separated by a salt,
Yes, ma'am.
right? So in
Yes,
this,
ma'am.
what I can say, if I have to write the E cell for this, okay, I said that it is the E cathode minus E anode always, right? So
Yes,
what
ma'am.
is cathode? Cathode is on the right side.
Yes.
I can write it like this, or either I can write it E right minus E left.
Uh-huh.
But by default, we have to consider that we are using the reduction potential. By default, it is always reduction potential that we need to use while calculating the E cell. Okay, because we have two types of reduction potential. Oxidation two. Standard electrode potential. Oxidation one and the reduction. Okay, so we can write that E reduction potential of cathode minus E reduction potential of anode. I can write it here. Getting?
Yes, ma'am.
What if I was am giving the oxidation potential, and how I calculate? So to convert the oxidation reduction potential to reduction potential, if oxidation potential is given, then we simply place a negative charge. Right? To convert it into oxidation potential, I will reverse this. And here, minus will get converted into positive.
Yes.
So if I have to calculate from reduction potential, well, I will use E cathode minus E anode. And if I have to calculate from oxidation potential, then I will use E anode minus E cathode. But in 99.9% cases, we always use this one.
Yes, ma'am.
It is important because in the numericals now, it is generally been asked that what is the E cell, how to calculate the E cell. While using the Nernst equation is also there. There you have to find out the E cell. Next is the thing is that we always use the reduction potential of cathode and what, but the thing is that how we get this reduction potential of a particular cell, or I can say that how to find out the electrode potential of half cell. So to calculate the reduction of electrode potential of half cell, we have a setup that is called SHE, that is standard hydrogen electrode. Got it? Getting?
Yes, ma'am.
Just have a quick revision of the above one and then I will start. Just revise the above one. Then we will start with it.
Yes, okay.
Then Tavya,
1 minute, ma'am. Done, ma'am.
well, the thing is that why we use the hydrogen electrode as the reference electrode. What happens in SHE is
Sorry.
we consider the hydrogen electrode as the reference electrode in SHE. Okay.
Yes, ma'am.
Why we use it as a reference electrode? Because hydrogen has a potential 0. Means E for hydrogen is always 0 at all times. Got it?
Yes, ma'am.
The hydrogen electrode can behave as cathode half cell as well as anode half cell. We were having two half cells. One is anodic one and the other one is the anodic one. So hydrogen has the ability to behave like that of cathode as well as of anode. Like in this H positive can be converted into H2. Means it can act as reduction, or I can say cathodic half cell. Also, it can undergo oxidation and can act as anodic half cell. Got it?
Yes, ma'am.
I have told you that the potential is zero at all temperatures. It means if I say that the E naught for H positive half H2 means the reduction potential is zero. Also, if I say that oxidation potential, are you getting that the difference? What is the difference between the cathodic half cell, cathodic reduction potential, or anodic oxidation potential?
Yes, I'm understanding the difference.
Potential. This is the oxidation potential. Understanding
Yes,
the
ma'am.
it is zero at all times. Now
Yes,
there
ma'am.
is a cell representation. Basically, we took platinum in this and we write it like this. Okay.
And your
What
voice is
happens with
breaking.
it? This is the cell representation that we represent, how we represent the assets.
Okay.
What happens is this. We took a beaker. Okay. In this beaker, we took electrolyte that is of 1 molar HCl concept. Got it?
Yes, ma'am.
We took one glass tube is there in which we place a platinum wire. Right. This is the platinum one. This one is glass tube. Okay. There is a slit basically through which we pass pure hydrogen. Pass pure hydrogen gas at 1 bar pressure. Okay. This is the platinum wire, or I can say that finally divided platinum. That is coated on aluminum. Got it?
Yes.
Why? Because the platinum has the ability to absorb hydrogen. That's why we took hydrogen, platinum. It
Okay.
absorbs hydrogen. Got it? See, when we pass hydrogen gas over here, this platinum will absorb the hydrogen. Get it?
Yes, ma'am.
When this hydrogen is absorbing the, like, it will absorb hydrogen to some limit.
Mm-hmm.
So it absorbs hydrogen, and the excess hydrogen that is available will comes out in the form of bubbles in the solution.
Yes.
Okay? This H2 is basically getting converted into H positive.
Ma'am,
Like
your
we
voice
are
is
passing,
breaking.
it is getting converted.
Ma'am, I can't hear
Like
you.
what is happening that we are passing H2 gas and it
Still cannot hear you, ma'am. One minute.
just now is it clear?
Yes, ma'am. Better.
So what is happening basically? This hydrogen gas that we are passing is getting converted into in the form of H positive ions.
Yes.
Okay. And the H positive ions that are present in the solution, H positive, these will get
Okay.
absorbed in the form of hydrogen gas on the platinum wire. Means
Yes.
these H positive will get converted into H. So what I am seeing here that the hydrogen is getting oxidation as well it is undergoing reduction.
Okay.
So that's why we took hydrogen. And how it works, it can perform both oxidation as well as reduction. Okay.
Yes, ma'am.
Any doubt?
No, no doubts, yes.
Next thing is that we are using SHG to find out the reduction potential of a half cell. This is my main motto. So how we use it basically? This we will. It measures E cell of magnesium. We have to find the potential of magnesium using SHG. Then how to do? Okay. What we do basically, we again took two half cells. Randomly, I have made one is of magnesium and other one is that I have taken is SHG.
Yes, ma'am.
Connected it by a salt bridge. Here I
Okay.
have placed a voltmeter.
Uh-huh.
Voltmeter is why voltmeter because it will measure the potential and that will be my potential for the cell. Got it?
Yes, I
I know
understand.
that the potential for SHG is always zero.
Uh-huh.
Okay? The potential for magnesium that I got, it is a theoretical and then we will do this, how practical it is. It comes out to be this. Okay? Got it?
Yes, ma'am.
If I consider that I have a anodic one, on anode there is a oxidation takes place. The one whose oxidation takes place will be the strong reducing agent. Can I say this thing?
Okay.
Yes. Okay. Anodic one, just for oxidation will be the strong reducing agent. Can I say this thing?
Yes, ma'am.
It will be strong reducing. The one who is strong reducing, will have the negative reduction potential because it is undergoing oxidation. Now, can I write it like this?
Yes.
And the one that is cathode. Cathode will undergo with reduction. The more the value of reduction potential, the more easily it will get reduced. Can I say this thing?
Yes, ma'am.
Okay. So the one with greater value of greater value of potential will undergo reduction, and the one with lesser value of potential will undergo oxidation. Correct?
Yes, ma'am.
Getting that? So in this case, it is having lesser value. So it will undergo oxidation. And it is having higher value, so it will undergo reduction. Correct?
Okay.
Okay. So
Yes.
if we practically do it, then we find out the E naught cell for this reaction. What is E naught cell? E cathode minus E anode. E minus E anode. Cathode is 0 minus 2.36. So on the voltmeter, we get the reading that is 2.36. By this
Okay.
thing, it is confirmed that we have used this formula. Okay.
Yes, ma'am. Got it.
So I can say that if standard electrode potential is negative, then what it will undergo? It will undergo oxidation. whose potential is lesser,
Lesser oxidation.
right? So I can say that if the standard electrode potential is negative, it means the reduction potential for hydrogen will be 0. So hydrogen will undergo reduction if the potential is negative.
Yes.
Getting or getting confused?
Yes, I understand it.
Understanding it?
Yes, yes.
If it is hydrogen that undergoes reduction, in which it means the reduced form of hydrogen is more stable.
Yes.
Because hydrogen undergo reduction, this is the thing that I want with. If the standard electron is negative, then hydrogen gas is more stable in its reduced form. Got it?
Yes, ma'am.
Is the concept clear?
Yes, yes.
Let's take another one. We have to find out the liquid potential of copper. Randomly, I assume that I have made SHE as anode. It is random and copper one as cathode. It is a random one I have selected. You can take any.
Yes, ma'am.
Okay. It is the SHE that I have made as anode. And for cathode, I have used the copper. Clear?
Yes.
I know that the liquid potential for hydrogen is 0. Got it? If I have to calculate the E naught of this cell, what I will write? E naught cathode,
One is not anode.
correct?
Yes.
The E naught anode is 0 because it is of SHE,
Yes, sir.
right? Anode 1 is the SHE. It is a random one I have picked.
Okay.
This E naught cell I will get from this reading.
Yes, ma'am.
Voltmeter will give this one. So here I have this one, I have this value. So I can find out this one.
Yes, sir.
So E naught for this case, E naught cathode for this case comes out to be
E naught.
0.34 volt.
Okay.
So the thing that I have said, the one with the more value of E naught will undergo as reduction because the reduction potential value is greater for this one. And the one with the lesser one will undergo oxidation.
Oh, yes, ma'am.
Right now, this is the thing that I told you earlier. So in this case, what I found that E naught for cathode is 0.34 and for anode is 0. So lesser one will be oxidation and higher one will be reduction. So it is the correct setup.
Yes, ma'am.
So it means that in this case, my cathode will copper will work as cathode and anode on SH. If I take the vice versa, like if I took copper as anode and SHE as anode, cathode, can I take this one?
Yes, ma'am.
Because it is just for the assumption. Huh? So if I find out for this case, E naught cathode minus E naught anode, my cathode one will be 0 now. Correct?
Yes, ma'am.
E naught for E naught anode will be this one. And what I found, E naught in anode in this case comes out to be 0.34 volt. Now what I can see that E naught cathode is 0 and E naught anode comes out to be 0.34 volt. So, but we have learned that the one with lower value will always undergo oxidation.
Yes.
So by this data, my zero will be the oxidation one because the zero value is lower now. Get it?
Yes, ma'am.
Okay. So according to this setup will be wrong because in this case it is getting reversed. The 1 with 0.34 volt potential can never say undergo oxidation. It will undergo reduction.
Yes, ma'am.
Getting?
Yes, ma'am.
So in this way, we can find that which one will undergo oxidation and which one will undergo reduction. Okay.
Okay.
Any doubt?
No doubt, sir.
Just to have a quick revision of it. If you can
Okay. Done, ma'am.
Yeah, Kavya, yesterday you have asked a question of organic chemistry.
Yes, ma'am.
Have you checked the answer again?
Ma'am, the answer is same only.
But I have
Paralite.
checked the answer. I checked it on internet, na. So on the internet, the order is same. That the most basic is the picnic one, then the para-nitrophenol, and then the carbonic acid.
Okay.
So just have a look over it again.
Ma'am,
What's the
do
answer?
you want me to send a picture of question?
Yesterday's one.
Yes, ma'am.
You have asked me. You were asking the question from me. Either the question is yours.
No, it was like from PW class, so I was asking.
Okay, it was on PW. So you are taking PW classes also, huh?
Yes, ma'am. For
Online
math
or
and physics.
offline?
Online only.
Okay. I think your question was this one. I told you the order is this one. And you were
Yes, ma'am.
saying the ma'am that the order should be this one, something like.
Yes, ma'am. H2CO3 is in between.
Yeah, you were good. Just check because on the internet, na, when you say that the acidity of para-nitrophenol and carbonic acid, which one
Yes,
acidity,
ma'am.
then only it is given this.
Okay.
Just have a check. Well, this is your today's class. Next topic that we will start is the Nernst equation.
Yes, ma'am.
Till then, just do the question practice to calculate how to calculate the E cell base.
Okay. Yes, ma'am.
Okay. I hope that electrochemistry is now much more clear to you
Yeah, a bit more
as
clear.
you have no idea about electrochemistry. Na?
Yes, ma'am.
Are you getting some confidence that you can do electrochemistry?
Yes, ma'am. A little more confidence.
Just try to do more and more questions and have a quick revision of the notes again and so
Okay,
that the
ma'am.
things will remember in your mind.
Uh-huh.
Okay.
Yes, ma'am.
Okay.
Thank you, ma'am.
So, बेटा, कर लेंगे ना काम कर लेंगे बेटा